here. So we can have it on the left. Alright. There we go. I hope this music actually isn't copyright. I can still get bad again. Usernames of your truncated. Okay. Okay. It's probably going to be a fairly quick stream. I just want to get through some of this section. Yeah, I want to get through some of this section because I've got other stuff I need to get doing. I was like, oh, might as well just do this, you know. Just a little bit ago. What the hell happened there? Alright. So last time we went over section 4. Made that work. Yeah. Since then, to be honest, I haven't really done it much. Just a bit of like optimization in a way and some rearranging the files, but everything is working. So we can just move on to the next section then. Alright, so in the last chapter we will source code transform into slightly higher level representations, a series of tokens. The parser will write the next chapter takes those tokens transform it. Again, before you could produce that representation of the code, you need to define it. That's the subject of this chapter. Along the way we'll cover some of the theory around formal grammars, feel the difference between functional and object-oriented programming, go over a couple design patterns and do some meta programming. Before we deal with that, let's focus on the main goal, a representation of code. It should be simple for the parser to produce and easy for the interpreter to consume. If you haven't written a parser or interpreter yet, those requirements aren't exactly illuminating. Maybe your intuition can help. What is your brain? It can help. What is your brain doing when you play the part of human interpreter? How do you mentally evaluate the arithmetic expression? Yeah, probably that first, isn't it? Because you understand the order of operation, that odd, please excuse my dear Aunt Sally stuff. You know that the multiplication is evaluated before the addition or subtraction. One way to visualize the precedence is using a tree. Leaf nodes are numbers and interior nodes are operators with branches for each of the leading operands. In order to evaluate an arithmetic node, you need to know the numeric values of subtrees, so you have to evaluate those first. This means working your way from leaves up to the roots. So, okay. If you gave arithmetic expression, you could draw on these trees pretty easily, given your trees evaluated at breakiness. Right, so we need to get some more. Wait, why is that like off the screen? Bro, what's a sad song? Fake love. But there's non-copyright stuff on Spotify, but like. I have no idea. Let's just have some background noise on this, so that I don't want anything sad. That's goofy. Alright, now let's chat the formalism. We used to define the lexical grammar, the rules for how the characters get grid triggers. There's a regular language. That was fine for our scanner, which emits a flat sequence of tokens, but regular languages aren't powerful enough to handle expressions which can nest arbitrarily deeply. Right, big words. We need a bigger hammer, and the hammer is context-free grammar. It's the next heaviest tool in the toolbox of formal grammars. A formal grammar takes a set of atomic pieces, it calls its alphabet, then it defines a usual infinite set of strings that are in the grammar. Each string is a sequence of letters in the alphabet. I'm using all these quotes because the terms get a lot confusing as we move from lexical to syntactical grammars. In our scanner grammar, the alphabet consists of individual characters and the strings are the valid lexemes, roughly words. In the syntactic grammar we're talking about now, we're at a different level of granularity. Now, each letter in the alphabet is an entire token and a string is a sequence of tokens. Okay. Maybe this will be an alphabet is characters, if the grammar tokens, a string is expression implemented by the scanner parser. Okay. A formal grammar's job is to specify which strings are valid and which aren't. If we are defining a grammar for English sentences, eggs on tasty for breakfast would be in the grammar, but tasty eggs for our tasty breakfast for our eggs would probably not. Yeah. How do we write down a grammar that contains an infinite number of valid strings? We obviously can't list them all out. Instead, we create a finite set of rules. You can think of them as a game that you can play in one or two directions. If you start with the rules, you can use them to generate strings that are in the grammar. Strings create this way of called derivations, whatever, because each derived from the rules of grammar. In each step of the game, you pick a rule and then follow it, I'm lost. You pick a rule and follow what it tells you to do. Most of the lingo around formal grammars comes from playing them in this direction. Rules are called productions because they produce strings of grammar. Each production in a context-free grammar has a head, its name, and a body, which describes what it generates. In its pure form, the body is a simple list of symbols. Symbols come in two delectable flavors. A terminal is a letter from the grammar's alphabet. You can think of it like a literal value. In the syntactic grammar, we're defining the terminals. The terminals are individual lexemes, tokens coming from the scanner, like F or 1, 2, 3, 4. These are called terminals in the sense of an endpoint because they don't lead to any further moves in the game. You simply produce that symbol. A non-terminal is a named reference to another rule in the grammar. It means play the rule and insert whatever it produces here. In this way, the grammar composes. There's one last refinement. You may have multiple rules with the same name. When you reach a non-terminal with that name, you're allowed to pick up any of the rules for it, whichever floats your boat. To make this concrete, we need to write down these production rules. People have been trying to crystallize grammar all the way back to, whatever that is, which codified Sanskrit grammar a mere couple thousand years ago. That's probably why I can't understand it. Not much progress happened until John Bacchus and company needed a notation for specifying Algol 58 and came up with Bacchus. What are these names? Since then, nearly everyone uses some flavor of BNF, tweaked on their own taste. I tried to come up with something clean. Each rule is a name, followed by an arrow, followed by a sequence of symbols, and finally ending with a semicolon. Pardon. Terminals are quoted strings, and non-terminals are lowercase words. Using that, here's a grammar for breakfast menus. Protein with on the side. Protein is another one of these. Cooked is one of these. Okay. We can use this grammar to generate random breakfasts. Let's play around and see how it works. By age-old convention, the game starts with the first rule in the grammar, hit breakfast. There are 3 productions for that, and we randomly pick the first one. Our resulting string looks like protein with breakfast on the side. We need to expand that first non-terminal protein, so we pick a production for that. Let's pick cooked eggs. Next we need a production for cooked, so you do poached, so poached eggs with breakfast on the side. The non-terminal is breakfast again. The first breakfast production we chose recursively refers to the breakfast rule. Recursion in this grammar is a good sign of language being defined as context-free instead of regular. In particular, recursion where the recursive non-terminal has productions on both sides implies the language is non-regular. We could keep the first production for breakfast over and over again, yielding all manner of breakfast, bacon with sausage and scrambled eggs with bacon. We won't though. This time we'll pick bread. There are 3 rules, each of which contain only a terminal. We'll pick English muffin. With that, every non-terminal in the string has become expanded until it finally contains only terminals, and we're left with this. There is some ham and Jose, and you've got eggs Benedict. Anytime we hit a rule that has multiple productions, we just pick one of the arbitrary. It is this flexibility that allows a short number of grammar rules to encode a combinatorial larger set of things. The fact that a rule can refer to itself directly or indirectly kicks it up even more, letting us pack an infinite number of strings into a finite grammar. Enhancing our notation. Stuffing an infinite set of strings in a handful of rules is pretty fantastic, but let's take it further. Our notation works, but it's tedious, so like any good language designer, will sprinkle a little syntactic sugar on top. Some convenience notation. In addition to terminals and non-terminals, will allow a few other kinds of expressions in the body of a rule. Instead of repeating the rule name each time you want to add another production for it, we'll allow a series of productions separated by pipe. Further, we'll allow parentheses for groups, and then allow within that to select one of the series of options from the middle of the production. So this would be like scrambled and eggs. Using recursion to support repeat sequences of symbols has a certain appealing purity, but it's kind of a chore to make a separate named sub-rule each time we want to loop. So we also use a postfix star to allow the previous symbol or group to be repeated 0 or more times. Well, hello Illusion Phones, how are you doing today? We had our first chat. Our first chat. We're just currently in the morning, just reading this Crafting Interpreter's book. But yeah. How are you doing, my friend? I hope my microphone's working. That'll be really embarrassing, wouldn't it? Okay, it is working. Alright, using recursion to support. Where was I? Like here, wasn't I? Oh, I'm good. It's a late night for me. How are you? Oh, for me it's the complete opposite. It's a nice good old morning. Yeah, I'm not gonna lie, I woke up probably about an hour ago and just got straight to it. Where are you based then, if you don't mind me asking, if it's late for you? It must be on a complete other side of the world to me then. Saw you on my recommended, just thought I'd stop by. Hey, thank you. At least we know live streams are coming through for people. So at the moment I've just been streaming and talking to myself, which sounds quite sad, but yeah, it's nice to have some company. Thanks for stopping by, mate. I am in Canada. Oh, Canada, nice. Yeah, definitely a place on my bucket list. I want to go there. It looks quite nice. I heard the winters over there are actually like quite extreme, very snowy. So, because I'm from the UK, so we literally get no snow. So it'd be nice to touch some snow for the first time in a long time. Postfix is similar, but requires a production to appear at least once. At least once, 0 more times. A postfix is for an optional production. The thing before it can appear 0 more time, but no more. All those syntactic necessities are breakfast grammar condenses down to protein. I don't mind listening to your stream while trying to sleep. Nice. Well, enjoy then if you really like enjoying listening to interpreters, then go ahead. Hope you're used to grab regular expressions in your text editor. Most of the punctuation should be familiar. The main difference is that symbols here represent entire tokens, not single characters. We use this notation throughout the rest of the book to precisely describe Lox's grammar. As you work on programming languages, you find out context-free grammars using this or EBNF or some other notation to help you crystallize your informal syntax design ideas. They're also a handy medium for communicating with other programming languages. But before we can do that, we need actual grammar for the Lox, or at least enough for one to get started. The grammar for Lox expressions. In previous chapter, we did Lox's entire lexical grammar in one foul swoop. Let's have a look here. My usual interest level, but it's alright, interesting. Yeah, fair enough. I mean, if you want to come, you can come watch and learn. Everything here is completely free. Yeah. Do you do any programming yourself? Because that's what we're trying to do now. There's a subset of languages, chapters for many language represented. Literals, numbers, strings, booleans, and nil. Unary expressions are prefixed and to perform a logical NOT and to negate the number. Binary expressions. Alright. This gives us enough syntax for expressions like. Right. It's our handy dandy new notation. Here's a grammar for those. Expression can be that. Literal. Okay, that's actually pretty useful. I should probably start writing this down, to be honest. I feel like that's quite a useful thing to do. If you call this a grammar? No, I haven't tried it at all. I feel like I'd have a hard time learning, understanding it. I mean, you joined the stream where we're doing probably one of the most complicated languages, like programming languages, but I feel like people kind of, I don't know what the right word is, but find it a little bit too difficult, or think that it's harder than it actually is. And that's coming from someone that's been doing it for a bit now, but like, it actually isn't that difficult. I feel like if you've got solid, like, if you can think, then you can pretty much write it. Especially because programming languages are written in English, so you won't really have a hard time with syntax and the grammar. But it's just logical thinking put into words, to be honest, and on the computer. It's simple. It's simpler than people think. It's just, it gets quite, I guess, overwhelming when people look at it, because you don't understand it. But when you can probably learn like a basic language and get like quite a lot going very quickly. Because it sounds quite sounds harder than it actually is, in my opinion. So it's kind of a demotivator for a lot of people. But yeah, no, the language I'm using now is like known as one of the more complex ones, because obviously there's easier languages and then there's harder ones. An easy one would be like Python, for example. Python was Python's quite simple. It's got very easy syntax, just like really good for learning and for beginners. This one's a bit more, if you want to get a bit, focusing on like speed and everything like that. So then it gets a little bit more complicated. But no, you probably won't have a hard time learning, if I'm being honest. Anyways, where was I? Alright. Let's get a markdown file for this grammar then. I'm gonna just scab this, just paste in here, because that's quite useful information. Do they have like some Unicode characters could be saved? I don't know, does this have any like quick functions? No, it doesn't. Well, that's a shame. So for me to make a bold, I've got to go like this. Oh, if I can. Wait, doesn't even change the color. Oh, what? Doesn't even change the color. Annoying. No, I don't really like that, to be honest. Alright, we'll just do, oh, no. Do you want to resave this file as Unicode and also maintain it? Yes. Okay. There's one bit of extra meta syntax here. In addition to creating strings for terminals that match exact lexemes for capitalized terminals that are single lexeme whose text representation may vary. Number is any number literal and string is any string literal. Later we'll do the same for identifier. This grammar is actually ambiguous, which we'll see when we get into parsing, but it's good enough for now. Now, I completely forgot what this word is, and it's really annoying. I'm not going to struggle trying to find it. One or more interpretations, not having one obvious meaning. Okay. Implementing syntax trees. Finally we get to write some code. Okay, fun. Less theory. We get to write some code, a little expression grammar and our skeleton. Since the grammar is recursive, note how grouping, unary and binary all refer back to expression. Our data structure will form a tree. Since this structure represents the syntax of our language, it's called a syntax tree. Our scanner uses a single token class to represent all kinds of lexemes. To distinguish the different kinds, think of the number 123 versus the string 123. We include a simple token type enum. Syntax trees are not so homogeneous. Unary expressions have single operand, binary expressions have 2, and literals have none. We could mush it all together into a single expression class with an arbitrary list of children. Some compilers do, but I like to get the most out of Java's type system, so we'll define a base class for expressions. Then for each kind of expression, each production under expression, we create a subclass that has fields for non-terminal specific to the rule. This way we get a compiler error to say if we say try to access a second operand of a unary expression, because I can only have one. Something like this. Oh, there you go. Abstract class, only binary. I avoid arbitrary class. Expr is a base class that all expressions inherit from. As you can see by the binary set, there's no technical need for this, but it lets us cram all the class to a single jar file. I actually don't know if we need to copy this down, or if it's just a sample text, because it usually tells you on the right if you should copy it down. This could just be like, I don't know if this is template code or not, but I will just create like a header file for it and just call it like expr. My chair's really low down, hold on. Alright, there you go. Now the clacky keyboard's gonna come out. So, an abstract class, just have to make the class out of that. That's binary extends expression. Huh, okay. So I'm guessing it's, can I just do this? Especially spell. Just gonna copy it for now because I'm not gonna really think about it that much. Create a constructor for a, so I need an exp left, a token operator. Oh, I can't really do that. Op and expr right. Is this not in my binary class? Yeah. So expr left. And we're back. So there we have it, token op and an expert. Right. And we'll just assign that to that. Left, op, and right. this is probably not the best because some of this stuff can be marked as cons, some of this stuff can be marked as like moved. So yeah, and this is probably like whatever. Alright, but for now we're just gonna leave it like that. So we're just gonna copy it off. X-ray is a base class that all expressions class inherit from. As you can see from binary, the subclasses are nested inside of it. There is no technical need for this, but let's just cram it all into a single Java file. Disoriented objects. You'll note that, much like the token class, there aren't any methods here. It's a dumb structure, nicely typed, but merely a bag of data. This feels strange in an object-oriented language like Java. Shouldn't a class do stuff? The problem is that these tree classes aren't owned by a single domain. Should they have methods for parsing since that's where the trees are created, or interpreting since that's where they are consumed? Trees span the border between those territories, which means they are really owned by neither. In fact, these types exist to enable the parser and interpreter to communicate. That lends itself to types that are simply data with no associated behavior. This style is very natural in functional languages like Lisp and ML, where all data is separate from behavior. It feels odd in Java. Functional programming, or whatever that says. Right now, I'm jumping to exclaim, see, object-oriented language is a bad fit for an interpreter. I won't go that far. You'll recall that the scanner itself was admirably suited to object orientation. It had all the mutable state to keep track of where it was in the source code, a well-defined set of public methods and a handful of private helpers. My feeling is that each phase or part of the interpreter works fine in an object-oriented style. It is the data structures that flow between them that are stripped of behavior. Now, metaprogramming the trees. Java can express behaviorless classes, but I won't say that it's particularly great at it. 11 lines of code to stuff 3 fields in an object is pretty tedious, and when we're all done, we're going to have 21 of these classes. Oh no. I don't want to waste your time or my ink writing all that down. Really, what is the essence of each subclass? A name and a list of typed fields. That's it. We are smart language hackers, right? Let's automate. Instead of tediously handwriting each class definition, field declaration constructor initializer will hack together a script that does it for us. It has each description of tree type and a name and fields, and it prints out the Java code needed to define the class, size, blah blah. The script is a tiny command line app that generates a file named expert.java. Okay, so this is where I'm gonna struggle, and I kind of want to get VS Code running with solutions. I was going to do this yesterday actually, but I just didn't. Visual Studio Code SLN. Okay, I hope it should still work, right? Let's exit this. And open up Visual Studio Code. Swift X. What the hell is this? Oh, it's one of my friend's websites. Whoopsies, probably shouldn't be showing that. Sorry. C, C++, locks interpreter. You know, let me YouTube it. Let's see what she's got to say. Oh, I don't trust her. 3 dislikes. See, that's the thing. So here, yeah. Install the correct. Because of this allows. See, this is where I don't, because I could be using CMake, but I don't think I actually have CMake. I have CMake. I thought I'd. Ooh. So now you're gonna be like complaining. Okay. What team am I even using? This one's actually really nice. Don't know what I'm doing. I'm kind of low-key just side questing right now. Anyways, well, I don't know if I should, what I should do. Don't know if I should translate or not. Right, I guess we're back to here then. Boo-hoo. That's probably silly of me. I should just started over CMake instead of in this Visual Studio. I don't really know how to use it, and I don't like it. Because I feel like I'm stuck. I'm forced to use this folder structure. Like, I don't want to do that. You know, how do I get out of this? I gotta. Can I add another? I can add a new filter. But how do I add a new folder? You know what I'm saying? Well, if I just want to add a folder. Okay. in Visual Studio, how do I see my file? Look at the top toolbar. There should be a small folder icon. I'm so confused. Hello? Where the hell is this icon? Hello? Oh. So is this it? That's hella ugly. I think I might just turn it into a CMA project because I don't understand it, to be honest. .12. Okay, that's me. Thank you, Vias. You have been lush. But I want you. I want you now. Development. Lock slash enter. Log slash interpret. Just gonna do that. That's probably like, that's what I can name it. Okay, yes, I trust authors. Alright, cmake list.txt. Hold on. Pasha. Clang isn't recognized. Clang plus plus. Men. Okay, let's G plus plus. What about G plus plus? For mature C++ and partial C++ 23, I've got GCC 12. Okay, cool. So I guess we can run it with GCC then. Oh, I literally can't with this. There she is. nice. Okay, and then for my thingy, I just need to oh my god. Just because I genuinely forgot. No, it's kind of embarrassing. Copy that. So I got my project, I got locks, printer. Configuration did fail because I don't have a main.cpp file. LXQ. Turn off capacitor. If I go to my terminal, CMake minimum version required. Okay, well, I've got that, so it's good to know. Optional include directory. Thingy. Yep, so include, and I'll also add source. Or are we chucking that in there? So all of this should work, executable. So then I collect OTP first. Actually, wait, can I? Project name, private. Source directory. So that includes, that's my include directories, and that's my source files. Whoa, why is it like a massive helicopter outside of my house? Oh my god, it sounds like it's about to blow up. Hello? That was random. Alright, cool. What the hell is cache? There's nothing in it. CMake. If I do go to my build, like I think I can CMake like this. Undefined reference to win main. I hope I don't. Yes, I'm right. Some stupid compiler warnings. Yeah, run it, run. Oh, that just runs G++. So I cd into the build directory and run cd.dot. Right. And then I build it. And then I run. Okay. Thank you for that, I guess. I just needed to know how to do that. I'm just gonna get rid of this cache, because why the hell do I need that? I don't know. Alright, so source files and include files. You, and you and you are coming over here. You are coming over here. So for you. And then token, scanner. Probably should have that in there as well. Okay, then this, and this. And this will be, let's go docs. I know this is probably not docs, but just a test. Alright, anyways, I think that should pretty much be it. So if I go to my expression, this is going to send me a billion warnings. I just don't need that right now. I think that should be fine. So then I just run no file or directory, standard format. But if I do this, it works. So I'm guessing it just doesn't see this, so it's not compiling at C++20. Let's see what she's got to say. Let's see what she's got to say. So now you're telling me this. Oh yes, now you're telling me this. Okay, so Plus you have no idea how you would do this on Windows. That doesn't work. Don't have Pac-Man. Don't know why I cancelled it. Oh my god. The computer's running so slow. It's awful. I forgot how you do this. Do you just copy it over? Do you run that?
GCC. We're going to install. Started. We want to go to.
Yeah, well, I've just downloaded something completely else. Nice.
In a verify button have a user. So just is of my C and C++ programs. So I'm going to go with the basic setup here, and then I'm going to select all these options from here. So just
So I need to what? Yeah, but then it's like I need an update, innit? Oh my god, this would be so much easier if if it was a Mac. I've already got everything set up on Mac. I just can't. I'm just trying to do it. Oh, okay.
the project for me to grab the various different packages that the command. No typing dialog. Hit close. That one either. And then I'm going to actually add in GCC. I'm going to do C out and options below. Basically,
to download. So going to don't 30 new things. So here is our this to keep on to that folder over here. Environment path, extracted and bin path. Now to wait, compile and D. And 2.2.2. If not, is not set to install.
Oh my god, I don't know why I've just clicked right, but I don't know. This is gonna just keep fucking loading or not. Alright, so I've got this bin. gcc.exe, g++.exe. Okay, so if I copy this, just copy it. And well, I don't know where you put it. You put it like a root or something in there. I just don't know what Okay, right. Let's would it be like dash path? I don't know, like alright. That makes sense. Alright, let me paste MinGW. BenjiW here. Alright. Go back to my environment variables then. Okay, I don't know. No, that's probably over. No, let's do I can't do that. Variable name. Browse directory, this PC, local disk. Restart my PowerShell. It's still the wrong version. I just delete that. What, these like sad songs, why these non-copyrighted songs are kind of sad, isn't it? See, that's what it should look like. But for some reason, in my environment variables, it's just set as this. Voice is the most So what if I type in GW there? Nothing in it. Okay, so I want to know why I install a new version of GC. Where G++, thank you very much. Alright, right now. So it's in my program files, yeah? Where's my PC go? So it's in my program files. Huh. Okay, we'll just I mean, if you want to be like that, then we'll be like that. Okay, well, hopefully this works. Oh. Get command g++.exe.path. How odd. Okay. And now it runs the correct G++ that I want it to run. And then I can just go bye-bye. And hopefully now all of this works, I guess. I might have to rebuild it actually. So detected a new GNU. Oh my god, it compiled. Oh my god, it compiled. Let's try that at that, okay. Run hello, it should return. Oh my god, and if I return with this, oh my god, and if I dn interesting. Well, that's just because different compilers work differently. Nice. Alright. Means you can go away. We recommend you install this. Okay, let's uninstall it then, I guess. Oh wait, why would I want to install CMake, man? What's wrong with CMake, man? I like my CMake. What's wrong with my CMake? Alright. I keep building up this cache. Okay, actually it has done something with that. Okay, cool. Anyways, there you go. So that's now actually up and running, finally.
Our player structure.
No, not our player structure. Perfect. Alright, so this is just because it's just because I want to make my own folder structure. I also just have a really good VS Code setup in my opinion. I just want to use. So. Why is now it's gonna break, innit? Oh my god, now you're gonna let me just write some code, man. Okay, thank you. Now write some code. Okay. Okay, nice. Alright. So this is gonna be a script. It's gonna be a script for this. View, but I want to open up cool. So generate, where are we? Generate data scripts. Alright, so we're gonna take an argument, so arg int argc sharp pointer argv array. If argc is not equal to 2, it's got double X Java over there. Then we'll standard Sierra usage. Oh, that should probably be that. Usage AST output 3. .64, and then standard string output 2, args at 1. It's actually on B. Okay. Note that the file is in different package.tool instead of .locks. This script isn't a part of the interpreter. A, B, C. That was actually better. It puts it down there. There's a tool with people hacking blah, blah, blah. Okay. So then we have a function for oh, it's bugging. Okay. So a function could define AST, which take our output there. So alright. So take our output there. We pass in some string. And then we create some array. And I'm pretty sure you can't pass just an array like that. So I'll create standard vector. Create standard vector. It's not going to be a vector because it's not going to dynamically change. It could be a std array. Standard string a size of 4. What are they? They're like, there are types, sorry, whatever, so it's just types. Binary. Expr left token operator. Expr right. Grouping. Expr expression. Literal. Object value and unary token operator expr right. Alright. So that's our array of types. Forgot what auto formatting on. Did it also auto format everything? Ooh. To be honest, I'm not too picky. So for brevity's sake, I jammed the description of the expression types into strings. Each name followed by the colon and a list of fields separated by commas. Each field has a type and a name. The first thing define AST needs to do is output the base expr class. Oh, because we're literally writing Java code. Okay. I should probably have thought about that. So, yeah, I should find a static. No, I was going to use this for inside this class. Static, auto. Define a standard string output the standard string base name and then a standard array of standard string. Ooh. I'm guessing because we're calling a function, that means we'll be doing other stuff except for just expr, right? For now, we'll do this, but for the future, something to maybe worry about. Oh, and it returns void. Forgot about that. Okay, so we have a standard string path, which can be our output dir plus a forward slash plus our base name plus .cp, because we're not doing a .java. Then we have a writer, which will write to the class. So write to the file. So this one I'm going to use standard OF stream. And you're tweaking that. Okay. the most unhelpful thing I've ever read. I don't know what it's done to my computer, but my computer not working right now. Oh, I've streamed my file. Okay, so let's just put file, give it something. What are we giving it? Path. Let's give it out. Path. And then we just write into it like that. Okay. So I could use an insertion operator. And I've got to close at the end. Okay. Not an issue. So, what are we writing? Hello? So into the file, we're going to write some lines. So we're going to write class, our base name. Oh, no, we're not. Standard format. 2025. Like, why are we not using this? We should be using this. Standard basic string is not a constant expression. Okay, so it's because of that. C plus string formatting. Hello? Hello? Are you struggling? Just... Oh, okay, that's not really what I want to do. So I'm going to ask GPT then, just quickly. I'm trying to... Just write that and see what happens. Oh, oh, they really made it difficult for us, didn't they? Okay, so that should write literally just a thing. Oh my god, okay. Okay, so I need to do standard F then. Alright, cool. So let's do that. And then that. Let's just do it how he does it here, because it will be a bit easier to see, I guess. I can just write a string here of a closing bracket. Ooh, and a new line character, of course. Alright, so far we've got a class and a class with a base name. Do C++ classes need a colon at the end? Where are you? Yeah, they do. Right, good spot that. When we call this base name is expr, which is both the name of the class and the file out virtual path. That's what now goes up there. So the base class, we define each subclass. So let's see what happens here. We loop over the types. We split it at okay. I'm not sure how do this in C++ because I don't think it has it. Okay. Interesting. So, side of here, we can do a for statement. We can do a standard string types. Not a problem. But then, the class name. I know there's like standard views. And I'm not sure if I'm gonna just write this. I'm genuinely not gonna struggle because I don't know. No. Okay, wait, there's an alternative. So I'm using it for last time. So with the type dot substring, so we're getting everything until type dot find colon. Tomorrow, thank God. So then okay, so here we can write a trim function. Have a function. Well actually okay. S dot erase, S dot begin, S find if, S dot begin. Well, this is awful, isn't it? S dot Oh. Wait, S to begin. And I think that's the end of the first erase. So to erase from the beginning of a string, because I'm guessing it's start and end, right? First and last, yeah. I think that means reverse begin, yes, reverse end. So it'd be the other way around. Oh my, what? What? That should be like that. I don't know why it does that, it's very annoying. But okay, so okay, yeah, whatever. Just gonna yank this as well, to be honest. Let's pause. Okay, so standard exit here. It's not thread safe. So let's try find the colon. Get last name. Actually, I'm pretty self-explanatory. This will be everything after position plus 1, with position being our colon. So our colon position. So everything from 0 to that is going to be our colon. I mean before our colon, and then everything after our colon. Okay. It's crazy how trim isn't like a standard library function. I feel like it should be by now. Okay. Our file. First name, last name, and field. Okay. Can I do that? Can I do base name, last name? No, I can't. Returns void. Yeah, file's gonna be with an issue on that. Yeah. But you can't just pass the file when you reference it. And then we get to write in. And am I going to format this one then? Class name. Isn't it like this? Class name, base name. Let's double check. Inheritance in C++. Yeah. Does inherit public stuff, yeah. Alright. Constructor. Forgot the new line character. Could have killed the whole world. Format. Okay, so I'm guessing that's tab. Just tab over that. Like class name. Open bracket. Field list. Closing bracket. And that. So I need my class name and my fields. Oh, and my new line character. Keep forgetting about this one. We've got store parameters in fields. Okay, actually, I'm actually getting really hungry. I might actually just take a quick break. The easiest way for me to do it. Oh, I thought that was meant to say. Anyways, I guess I'll be right back and then we'll carry on from there. Because I'm hungry. Need to make some food. Alrighty. Back and better than ever. But I think I don't know how much longer we've got on this. Actually, decent amount, to be honest. Okay. I think we'll carry this on next stream. So at the moment, I don't think I can't be bothered. I've got other things to do at the moment, which is sounds as bad as it does. But I actually do have things I need to do first. So maybe later, but we'll see.